Good morning, my name is Eric Romo. I am the DS23 tutor at Fresno City College, and today we'll be talking about the geometric mean. Today we'll be working with a practice example that you can actually apply to a couple of your problems to practice for your test. So, the number of graduates from Brown State increased from 5,000 to 10,000 in 10 years. Based on the geometric mean, the university grew at an average rate percentage of question mark. Well, I guess that's what we're going to be solving for today. So, first let's go ahead and write down what the geometric mean equation is. Okay? 1 plus r sub 1, 1 plus r sub 2, all under this bracket of the roots 1 plus rn. And on the outside we have minus 1. Okay? So, what we're looking for in here are each different rates that we are comparing and multiplying inside the radical, which here n represents the time period. So first things first, n is the time period. Well, it looks like they did give us a time period of 10 years. So I know that n must equal 10. Alright, so what do we do next? Well, it says that they increased from 5,000 to 10,000. If that's the case, and there's no other rates given to us, then that means that it was a constant increase, okay? So if I were to graph this from year 0 to 10 years, this is my x, and this is my y, okay? The slope, let's do a quick slope review, okay? In year 0, it's 5,000 students. And in year 10, it was 10,000 students. Given this information, I just took this from the problem, okay? Just to understand what's going on here. So, y2 minus y sub 1 over x2 minus x of 1. So, I'm going to take each of my points. This is point 1 and this is point 2. So I get 10,000. 1, 2, 3, minus 5,000 over 10 minus 0. So I get 5,000 divided by 10, which in turn becomes 500. So 500 students at a constant rate. So really what's going on here is a linear function. Up here is going to be 10,000 students. Okay? So this is an important concept here because geometric mean compares different rates of growth. Okay? Now, if this is a constant function, then I can assume that the rate has never changed and that there's only one rate that I'm working with, r sub 1. Okay? So really we're going to be looking for this. So how do I find that? Well, what we do is that we're going to take 10,000 minus the 5,000 and divide it by the original population. Because here we're going to find a rate. So I get 10,000 minus 5,000, that's 5,000, divided by 5,000, which is in fact equal to 1. If I times this by 100 to get a percentage, I get 100% in growth. Okay? But let's just keep it in this form for now. so that I can plug it into my original equation. So R of G is equal to, what is my time rate? It's going to be 10. Okay, so that's my time period. 1 plus the rate. Okay, remember each of these represents a different rate, but we only have one rate that we're talking about, which is this m. So I'm going to take this value right here, 1 plus 1, this is where this is coming from, right here, okay, and take it to the 10th root. Well, I need to simplify. So R sub g is equal to 10th root. Oh, don't forget the minus 1. 10th root of 2 minus 1. Well, and if we put this into our calculators, okay, I'm going to open up my calculator right here. Calculator. Okay, I'm going to take 2 to the 10th root, so I need to put in a parenthesis here, 1 divided by 10, which is the same as saying to the 10th root, equals, okay, I got this really big number. But notice, down here, I have a minus 1, okay? That's accounting for this 1 in here. So I need to go back into here. So I'm going to write, I'm going to go about, I'll say, this many decimal places, rounding. Okay? So whatever this is minus 1, R sub g is equal to 0.071 or 7.1%. And that is, in fact, my average percentage of growth. And that's all there is to it.